Hello and welcome to Patshaala. This is Andrew, and today's class is on real number, part 1, and it's for class 10 for both SEBA and CBSE. The first question of our class is use Euclid's division algorithm to find the HCF of 135 and 225, and the rest of the questions we will discuss later in this class. So first we will take 135 and 225. From here we will take the larger number. The larger number is 225. This is 225. So now by Euclid's division algorithm, division algorithm, we have 225. We will equals to, we need to divide 225 by the other number, which is 135. So if we divide 225 with 135, it will be divisible only one time. So 1 into 135, and the remainder, we will get some remainder, which is 90. We will get 90, and the remainder we need to add in the last. This is the Euclid's algorithm. Okay, now again, next 135, this 135 we will take, and we have to divide it by 90. So only one time, because 91 is a 90 and 92 is a 180. So 180, it is 135 is smaller than 180, so only 1 into 90, then the remainder we will add here, which is 45. Okay, now we will take this 90 equals to 90 and divided with 45. So now let's see, 45 ones are 45 and 45 twos are 90, so we can divide it by 2. 45 into 2, and remainder, there won't be any remainder, so we don't need to write, and here we will stop the process. Now let's see, therefore we get what? HCF of 225 and 135 equal to HCF of 135, this line 135 and 90 equals to HCF of 90 and 45. 90 and 45. How much we got? In last we will get only 45, so it is equals to 45. So therefore the HCF of 225 and 135 is 45. This is the answer. Now the second question, which is 196 and 38,220. So similarly we will take the greater number. The larger number is 38,220. So by Euclid's division algorithm, I am writing in a short form, by Euclid's division algorithm, the same way we will proceed. 38220 equals to, now we need to divide this number by 196. 196, if we divide with by 196 to 30,220, we will get 195. So we can check this 196 and 195. We will get 195. So let's do it and see. 6 5s are 30, 0 3 5 6 9 is a 45 48, then 4 5 5 plus 4 is 9 9 6 ja 54 5, then 9 9 is 81 81 plus 5 is 86 86, then 9 1 is 9 9 plus 8 is 17, then 6 1 is 6 9 1 is 9 1 1 is 1 0 2 12 1 2 10 20 2 into 7 plus 9 is 16 plus 2 is 18 8 1, then 1 2 3 3 8. So we can see that 38,220. So what we will do is 196 into 195 plus remainder. We did not get any remainder, so it will be 0. You can write, and if you don't want, you don't need to write the 0. It depends on you. So in one line the sum is completed. So now we can write, therefore HCF of 3 8 2 2 0 and 196 equals to 195 is 195. Therefore the HCF of 196 and 38220 is 195. So this is the answer. And the third question is 867 and 255, and again we will take the larger number. The third question is 867 and 255. Here the larger number is 867. So 867, and by Euclid's division algorithm, 867 equals to, we need to divide 255 with 255. So we will get 3 times 3 into 255. You can check it in the draft, and plus remainder we will get 102 in remainder. Okay, again now we will take 255 equals to, how many times we can do with 102. 102 we can divide it with by 2 times 102, then we will get a remainder 51. And now we will take again 102 equals to by 51. It clearly we can see that 51 into 2 will be 102, isn't it? 2 into 51. So the HCF of remainder will be 0. If you want, you can write. If you don't want, it's about you. HCF of 867 and 255 equals to HCF of this and this equals to HCF of this and this. HCF of 255 and 102 equals to HCF of 102 and 51 equals to, how much we got? Answer will be, this will be the last one, so 51 will be the HCF. Therefore the HCF of 867 and 255 is 51. This is the answer. Now question number 2. So that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. Okay, so q is some integer, and we know, so We know Euclid's algorithm. We know Euclid's algorithm is x equals to bq plus r. So here r will be between 0 and b. Here r is between 0, r will be greater than equal to 0 and smaller than b. Let's take it as equation 1. Okay. And in the question, the value of, here we can see 6q plus 1, 6q plus 3, 6q plus 5. Here we can see the, if we compare this equation with the Euclid's division algorithm equation, we will find the b is 6. Everywhere we can see 6. So we will get, so b will be equal to 6. It is given in equation. And r's value will be equals to from 0, 1 2 3 4 5, only till 5, because b is 6, it will be smaller than 6, then it can come up to 0, 0 equal to 0 also, and 1 2 3 4 5, because b value is equal to 6 here in the given equation. So it will go till 0 1 2 3 4 and 5. So now let's check for 0 first. If r is equal to 0, what will be the equation? X equal to 6q plus 0. What we will get is, the equation is divisible by 2. See, we will get 6q. If you put the value of q anything, 1 2 3 4, it is said that it is some integer. If you take 1 2 3 4 anything, 6 1 is 6, we will get the even integer. 6 2 is 12, we will get the even only. 6 3 is 18, it will get even. So we will always get even. Okay. And again, for if we take r equal to 1, x equal to 6q plus 1 equal to, it will be odd number, which is not divisible. Odd means it cannot be divisible by 2, because if we put 1 in the place of q, we will get something like, if you put 1, then 6 plus 1 is 7, then it will be odd. If you put 2, 6 2s are 12 plus 1, then it will be 13, it will be odd. So it is not divisible by 2 and it is odd number. If we keep r equal to 2, x is equals to 6q plus 2, we will get even number. We can check it out. 6 1s are 6 plus 2, then it will be 8, which is even number. 6 into 0 you can give, then also 6 into 0 is 0, plus 2 will be 2, 2 is an even number. So similarly, r equal to 3, x equal to 6q plus 3, we will find odd number. And if r equal to 4, we have to do it for all the numbers. R equal to 4, so x equals to 6q plus 4 equals to, we'll get even number. And if r equal to 5, x equal to 6q plus 5, we will be getting the odd number. So we have done for all, we have checked for all the value of r till 5. So, or therefore, we can say that, or we find that the number 6q 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 plus 1, 6q plus 2, 6q plus 3, 6q plus 4, 6q plus 5 are either even or odd. Are either even or odd number, but in the question you can see we need to find the positive odd integer. Positive odd integer. Here the odd numbers, all are positive integers, but odd numbers are these. Here we will find the odd number. This is the odd number, this is the odd number, and this is the odd number. So we need to get those numbers. So therefore any positive odd integer is of the form 6q plus 1, 6q plus 3, and 6q plus 5, where q is some integer. So this is our answer. Okay, and here is our third question. The question says an army contingent of 616 members is to march behind an army band. They are going to march behind an army band of 32 members. The band member is of 32 members in a parade. Two groups are to march in the same number of columns. They have to march in the same number of columns. What is the maximum number of columns in which they can march? And we need to find the maximum number of columns in which they can find. That means we need to find the HCF of these two numbers. The HCF will be the answer of the question. Okay, let's see. From these two numbers, so we can write the maximum number of columns would be the HCF of 616 and 32. Now by Euclid's division we need to find the HCF of these two number. So in Euclid's division we take the greater number. So by Euclid's division algorithm, in short form, Euclid's division algorithm, the greater number is 116 equal to, we need to divide 116 by 32. Then how many times we can get is, it is 19 times. 19 into 32 plus remainder will be there, it is 8. You can check it out. And we will take, now we will take 32 equals to, with 19 we have to divide it now, sorry, with 8, with the remainder, so which is 8. So 8 how many times? 4 into 8, then we will get 0 remainder. So here we get a 0 remainder, so we will stop here itself. So the HCF of, HCF of 616 and 32 is, what we get is 8. So therefore I'm writing in short form, maximum number of columns in which they can merge is 8, and this is the answer. See, the answer is very small and very easy and simple. Don't be afraid by looking at the questions might be very long, but if the question is very lengthy, it is very good for you that they gave you in a explanation, they gave you the descriptions, so we can find it very easily. Don't get afraid. And this is our question number 4, which will be our last questions for today's class. So the question is, use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m, for any integer m. Okay, now let's start doing it. According to Euclid's algorithm, we know that x is equals to bq plus r. So let's take it as an equation 1. So here in the question we can clearly say that the value of b will be 3 in both the cases. 3 q plus 1, like that. So 3. So now let's substitute b equal to 3 in equation 1, and b equal to 3, and value of r will be equals to 0, 1, 2, and it will not go more than 2 because the value of r is always greater than equal to 0 and smaller than b, and the value of b is 3, so it will be smaller than 3 and it will be equal to 0 and in between 3 and 0. So 1, 2, 3. So when r is equal to 0, equation 1, we will use the equation 1. Equation 1 implies x is equals to 3q plus 1. 3q plus 1, and when r is equals to 1, equation 1 will be x equals to 3q plus 2. Why 2? Because 1, 3q plus 1, and here will be 0. Actually 0 we can write, 3q, my mistake, I'm sorry. 3q, only 3q we can write, and here 1, r is 1, so the value of r will be 1 to 3q plus 1. And if you take r equal to 2, then what we will get is equation 1 implies 3q plus 2. Okay, so now let's square these equations. Let's take this equation as equation 2, and this equation as equation 3, and this will be as equation 4. Okay, now let's square equation 2, 3 and 4. By squaring equation 3 and 2, 3 and 4, squaring to equation 2 and 3 and 4, we get From equation 1 we will take first, sorry 2. From 2 what we will get is, if we square this we will get x square restings x square equals to what, 3q 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 square. 3q square means 3q square, that means that we will get x square equals to 3 is a 9, 9q square we will find. Okay, now again okay, but now we have to make it as 3m, we have to bring in this form. So here what we can do is x square, and this one we need to break, then what we will get, 3 into 3, we can write 3 into 3 9, then q square. So we can write 3, and these things we will be writing as m. So we will give here where m is equals to 3q square. See, we have taken this number as a m, taken these values as m. Okay, now we will do the equation number 2 in the same way by squaring both sides. So now for the equation 3, next one. So similarly we will do as of equation 2. So from equation 3, so equation 3 is, this is the equation 3 after squaring. Okay, after this it will continue this way, squaring 2 3 4 we get, then from 2 we have done, and from 3 now we are doing after this. So what we will get by squaring, x square equals to 3q plus 1 whole square. Okay, what we will get is x square equals to, so it will be in the form a square plus b square plus twice ab. So it will be a square means 3 3 is a 9, 9q square plus, so b square is 1 square means 1 plus twice ab. 2 into a is 3, 2 3 is a 6, a is also 1, so 6 1 is 6 only, so q 6q. We understood this or not? It is in the form a square plus b square plus twice a b. So next we will proceed. 9q square plus 6q plus 1, and here we will get, we can take some common. The common can be from these two number will be 3. We can take 3 3 is a 9, so 3q square plus again here 2q, isn't it, plus 1. So where what we will get the common is 3, so we can take 3 here from here, so 3, and if we take this number as m plus 1 it will be, so we will write where m is equals to 3q square plus 2q. So here we got x is equals to 3m plus 1, and this is done for the equation 3. And now we will do for the equation 4, which is x equal to 3q plus 2. From equation 4, so squaring both sides, qx square equals to, similarly 3q plus 2 we will be doing the whole square, that means, so 3q means a square means 3 3 is a 9, q square plus 2 2 is a 4, b square then plus twice ab, 2 into a is 3, 2 3 is a 6, 6 2 is a 12, 12, then q, okay, it is in the form a square plus b square plus twice ab. So we will arrange it, 9 square plus 12q plus 4. So we'll take the common of this, so we'll get 3 again common from here. So 3 3 9 square, see 3 gone there, 3 3 is a 9, 9 square we can write like this, plus again 3 from 3 4 is a 12, isn't it? So 3 is already outside, so 4 will be there, so q plus 4. Okay, this 4 we can break this 4 into we can write this 4 as this way, 3 plus 1, 3 plus 1 is 4, we can write it in this way. So we can take this 4, all this number is also in a common, so okay, we will cut this line and we'll do it again. Okay, so we can write this 4 in this way, 3 plus 1, okay, I'm sorry. Okay, now see, let's take 3 as a common, 3, then 3q square plus then 4q, then again from here also we are taking this whole in a common of 3 plus 1. If 3 goes outside, then it will be 1 because 3 ones are 3, then plus 1 left, so 3, and these holdings we can write as m and plus 1. Okay, where m is equals to 3q square plus 4q plus 1. So we have reached to the end of the exercise, and the answer of this is hence or so any positive integer is either of the sum, either of the form 3m plus 1 for some integer m. So 3m we get in this here in the first equation, and here also we are getting 3m plus 1, and 3m we got it in the equation 2 here. From here we got 3m, so 3m we got, so it is in the form 3m and 3m plus 1 and 3m plus 1. So these two are the equations we got. So nothing is here, it is not much lengthy, you can check this way. First we have taken, you place algorithm here, 3 b value of b is given as 3 and the value of r will be 0 1 2. Then we have substitute the value of rn b in the Euclid's algorithm, which will be this in this form. So we have named it as equation number 3 2 3 and 4. Now squaring all the equations separately, so we have got for the first equation 3m, and for the second equation 3m plus 1, and the last one 3m plus 1. So the any positive integer is either in the form of 3m or 3m plus 1 for some integer m. And this is the end of the exercise exercise 1.1 real numbers. And if you want the next part, if you want to continue with the next part, subscribe to my channel Patshaala, subscribe to my channel Patshaala, and press the bell button for the notification, so that you get the notification as soon as the video is uploaded. So hope you have enjoyed the class and have you understood. And if you have any doubts or issues regarding the sums in mathematics, so please comment me in my comment box. And here I am signing off. Thank you and have a great day.